Use the rainbow strategy to find all the factors of the numbers listed below. Applying the divisibility rules you've learned can save you a lot of time, so use them. Okay, you're going to do 3 problems. I'll show them on the screen here one at a time. You'll have time to solve it on your own, and then you'll submit your answer here. After you submit your answer, the screen will automatically play and go over the answer with you. We'll do that for each of the 3 problems you're going to complete on your own. So start with number 1, find all the factors of 24, and submit your answer when you're ready. Let's review this problem together. I'm going to use the rainbow strategy to solve. Check your work along with mine and make corrections as needed. I'm going to start with 1 because 1 is a factor of every number. It will always be written down, right? And 1 times 24 equals 24. Next, I'm going to go on to 2. Is 2 a factor of 24? Well, if I look at the ones place, I see that it's an even number, right? Which means that the whole number is even, and it means that 2 is a factor. Now, I know my basic math facts up to 12s, and I know that 2 times 12 is 24. So finding the other factor there when you know your basic math facts is nice and easy. If you don't know that basic math fact, you can think of 24 as 20 and 4 and split each of those in half to solve it mentally. Half of 20 is 10, half of 4 is 2. Put them together, 10 and 2 is 12. Or you could do the long division. You've got choices here. Next, let's check 3. Is 3 a factor of 24? Well, again, I'm going to think about my basic math facts, and I know that 3 times 8 equals 24. So yeah, sure, 3 is a factor. So we can write down 3, and the other factor is 8. 3 times 8 equals 24. And now let's go on to 4. This is another one. I can write it down right away because I know that 4 times 6 equals 24. So I'll put 6 as my other factor. And now I only have one number left to try, 5. So let's check the rule for 5. I know that if a number has the digit 0 or 5 in the ones place, the number is divisible by 5. And this number has a 4 in the ones place. So 5 is not going to be a factor, or 24 is not divisible by 5. And then the next number after 5 is 6, and I'm right back to a number that I've already written down, which means that we have tried every single option. So I am all done. But this isn't how we're going to write our answer. This isn't an answer. This is a strategy for how to solve to find all the factors. So now I'm going to write them in list form. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And that's my final answer. Now try this one. Find all the factors of 64. Submit your answer when you're ready. Okay, check your answer before I go over this. There are 7 factors of 64. Did you find 7 factors? If you didn't find all 7 factors, take a moment to identify the ones that are missing. Go through it step by step, trying each number the way that we learned before clicking continue. If you have more than 7, go ahead and check your work and see which ones don't belong. Click continue when you're ready to review. As always, we'll start with 1 because 1 is a factor of every number. 1 times 64 equals 64. Now we'll try 2. Is 2 a factor of 64? Well, if I look at the ones place and see a 4, that's an even number, which means that 64 is an even number and all even numbers are divisible by 2. So yes, 2 is a factor. Now you can either do long division or you can think about it mentally like this. 64 is the same as 60 plus 4, right? And then you can probably find half of 60 in your head and half of 4 in your head because finding half of a number is the same as dividing it in 2, right? So half of 60 is 30 and half of 4 is 2. And if I put those together, that will be half of 64. So Half of 60 is 30, half of 4 is 2, 30 plus 2 equals 32. So that's my other factor. 2 times 32 equals 64. Now on to 3. Is 3 a factor of 64? Well, one way to determine this would be to do the long division and see if you end up with a remainder or not, right? If you don't have a remainder, then it is a factor. And if you do have a remainder, it's not. But this is when knowing the divisibility rules can save you a lot of time, because you can check the divisibility rule first. So let's review that together. The divisibility rule for 3 is that if the sum of the digits in the number is a multiple of 3, then the entire number is divisible by 3. So the sum of the digits in 64 are 6 and 4, and sum means addition, so we're going to add them. 6 plus 4 equals 10. So if 10 is a multiple of 3, then 64 is a multiple of 3. Is 10 a multiple of 3? 3, 6, 9, 12? No, it's not. So that means that 64 is not a multiple of 3, or 64 cannot be divided equally by 3. So do we need to waste our time doing the long division here? No. Once when we check the rule and see, no, it's not going to be a multiple, we can skip over 3 and go right to 4. Is 4 a factor of 64? Now for 4, we're going to have to do the long division. So let's do that and check. Remember, if we get a remainder, then 4 is not a factor. And if we don't get a remainder, then it is. 4 goes into 6 one time. We're going to multiply and then subtract. We get 2. Now we bring down. Now we check how many times 4 can go into 24. 4 can go into 24 6 times. We'll multiply, we'll subtract, we end up with 0 and no remainder. So is 4 a factor of 64? Yes. We'll go ahead and write down 4, and the other factor is 16. 4 times 16 equals 64. Now we go to 5. Is 5 going to be a factor? Well, we know that if a number has the digit 0 or 5 in the ones place, the number is divisible by 5. And when I look at the ones place here, I see a 4. So 64 is not divisible by 5. Now we'll go on to 6. And we can use a little mental math to solve this one because it's really close to it's within our basic facts. So in my mind, I'm going to think of a fact close to 64. For example, I know that 6 times 10 equals 60, and that 6 times 11 equals 66. And 64 is between 60 and 66, but there's no number between 10 and 11, right? So 64 is not going to be a multiple of 6. We'll go on to 7 now, and we're going to do the same thing. Think of a fact that's close to 64. For example, I know that 7 times 10 is 70, and that's too high, so now let's try 7 times 9. That's too low, and there's no number between 9 and 10 to try. So no, I won't be able to multiply 7 by any whole number to get 64. So 7 is not a factor. Now let's try 8. Is 8 a factor of 64? Again, we're going to need to use our knowledge of our basic facts, right? I know that 8 times 10 is 80 right off the top of my head, and that's too much. So I'm going to go down and check my facts. If it doesn't pop right into my mind, that's a strategy to use. Let's see. 8 times 9 is 72. 8 times 8 is 64. Oh, that's the number that I wanted, right? So 8 is a factor. I can write down 8, and it was 8 times 8, which equals 64. And there's no number between 8 and 8 to try. So I have found every single factor of 64. But this isn't how I'm going to write my answer. Again, this is just the strategy for finding them all. I'm going to list my numbers now. 1, 2, 4, 8, 16, 32, and 64 are all factors of 64. Notice how I didn't write 8 twice, right? 8 is a factor of 64. You don't need to say 8 is a factor of 64 and 8 is a factor of 64. It only needs to be listed once. All right, last problem. Try number 3 on your own, and then we'll go over it together. Find all the factors of 120. This is your last practice problem. And there's a lot of factors, so take your time and try to get them all. Use the rainbow strategy to make sure you're not skipping any factor. Don't go on to the next number unless you've determined that a number is or is not divisible by 120. For example, when you're determining if 7 is a factor of 120, don't just guess yes or no and go on to 8. Actually do the long division or apply a rule if you know one. Hint, there is no rule for 7. We start with 1 because, again, 1 is a factor of every single number. 1 times 120 equals 120. They're both factors. Now let's check if 2 is a factor. We're going to check to see if the number is even. So let's look at the ones place. Yes, this is an even number, so 2 is a factor. Now we have to find the other factor, so we have to do 120 divided by 2. Another way you can think about this in your mind, if you wanted to try it mentally, is what's half of 120? Sometimes when you think about it like that, the answer pops into your mind a little bit easier. Or you might want to think of 120 like 12 tens, and then think, what is half of 12 tens? Because you can probably do half of 12 in your head, right? That's 6. But it was 12 tens, not 12 ones. So it would be 6 tens, or 60. So the other factor is 60. 2 times 60 equals 120. Now let's go ahead and try 3. Let's review the rule, because that'll help us out here. If the sum of the digits is a multiple of 3, then the entire number is divisible by 3. Let's add up the digits. 1 plus 2 plus 0, which is going to add nothing, right, equals 3. So is 3 a multiple of 3? Yeah, it sure is. That's the first multiple of 3. So now when we do the long division, we know that we're not wasting our time. We know that we should not get a remainder. 3 can go into 120 equally. So 3 can go into 12 4 times. We now multiply, we subtract, I get 0, bring down the 0. 3 can obviously go into 0 0 times, and we can stop there because it's just going to still be zeros, right? We're done. So the other factor is 40. We can write 40 down, and 3 times 40 equals 120. What I wrote off to the side is another way to kind of think about this mentally. You could have done 120 divided by 3 in your mind if you thought about it like 12 tens divided by 3, right? 12 divided by 3 is 4, but it wasn't just 4, it's 4 tens, or 40. Okay, now let's check 4. Is 4 a factor? Well, we don't know a rule for 4. We haven't learned that one yet. So we're going to need to do the long division. Let's do that. And if we don't get a remainder, then 4 is a factor. 4 can go into 12 3 times. We multiply, subtract, bring down. 4 can go into 0 0 times. And again, we can stop right there because 0 times 4 is 0, and we have nothing left to bring down. So 4 is a factor, right? It goes in equally, and 30 is the other factor. So I can write down 4 and 30. 4 times 30 equals 120. Now we'll try 5. If a number has the digit 0 or 5 in the ones place, the number is divisible by 5. If we look at the ones place, it's a 0. So 120 can be divided by 5 without getting a remainder. 5 will be a factor. So let's write it down, and let's do the long division to find the other factor. 5 can go into 12 2 times. 2 times 5 is 10. We'll subtract, bring down the 0. 5 can go into 20 4 times. 4 times 5 is 20. We'll subtract. We get 0, and we have nothing left to bring down. And since we have a 0, we have no remainder, right? So the other factor is 24. Let's write that one down. 5 times 24 equals 120. Now on to 6. We don't know a divisibility rule for 6 yet, so we're going to have to do the long division. 6 can go into 12 2 times. 2 times 6 is 12. We're going to subtract. We get 0. Bring down the other 0. 6 goes into 0 0 times. And we don't have to continue going on because 0 times 6 is 0, and there's nothing left to bring down. We have no remainder. So 6 is a factor. We could have also tried to solve this mentally by thinking of it as 12 tens divided by 6. Since 12 divided by 6 is a basic fact, it can be solved in your head. 12 divided by 6 is 2, but it wasn't just 12, it was 12 tens. So the answer would be 2 tens. So that's just another way to think about it if you wanted to try to do it mentally. All right, so 6 is a factor. Let's write that down. And the other factor is 20. I'm running out of space here, so I'm going to make that a little bit smaller. 6 times 20 equals 120. Now on to 7. We haven't learned a rule for 7 yet, but actually there is no rule for 7. You always just have to divide. So let's do the long division. Let's do it where I have some space down here. 120 divided by 7. 7 can go into 12 one time. I'll multiply and then subtract. 12 minus 7 is 5. Let's bring down that 0. Now I'm going to say how many times 7 can go into 50. 7 times 7 is 49. So that's as close as I can get without going over. I'll put the 7 in the quotient, and now I'll multiply. 7 times 7 is 49. I'm running out of space here, but if I subtract 50 minus 49, it's 1, right? And I have nothing left to bring down. So that means that the answer is 17 remainder 1. So is 7 a factor? No. 7 cannot go into 120 equally. So we won't write down 7. We'll go on to 8. And again, we don't know a divisibility rule for 8, so we're going to do the long division. 8 can go into 12 one time. We multiply, we subtract. 12 minus 8 is 4. I'll bring down the 0. 8 can go into 40 5 times. We'll multiply. 5 times 8 is 40, and we'll subtract. If I subtract, 40 minus 40 is 0, and I have nothing left to bring down. So that means that I have no remainder. So 8 is a factor of 120. 8 times 15 equals 120. 8 and 15 are factors. Oh, wow, we've got a big list going here. All right, on to the next number. We've tried 8. Let's go on to 9. This is another one. We're just going to have to do the long division. There is a rule for this one, and you're actually going to learn it today. So once when you know the rule, it'll make this step a lot faster. So 9 can go into 12 once. We'll multiply. We'll subtract. We get 3. Bring down the 0. 9 can go into 30 3 times without going over. 3 times 9 equals 27. And then we'll subtract. I've run out of space, but 30 minus 27 is 3, and I have nothing left to bring down. So the answer would be 13 remainder 3, which means that 120 could not be divided equally by 9, and 9 is not a factor. So now we're going to go on to 10. Yay, there's a rule for 10. If I look at the ones place and it has a 0 in it, it means that 10 is a factor, or that it can be divided equally by 10. So 10 is a factor here. 10 times what equals 120? Well, that's a basic fact that we probably know, right? 10 times 12 equals 120. So let's write down the 10 and the 12. Notice that I put the 10 on the left side and the 12 on the right side. You want to make sure that this list goes in order so that you're aware when you get to the center point. All right, so 10 times 12 equals 120. And now it's so many numbers here, but we have not yet tried the number here. We have not yet tried 11, but only 11 is left. So it can't be 11 times 20 or 11 times 12 because we've already tried every other number. So the only thing we have left to try is 11 times 11. And I know that 11 times 11 equals 121. And if you didn't know that, you could do the multiplication or some mental math to figure that out. But that is not 120. So 11 is not a factor. So now I've tried every single number and I've found every single factor. So now let's go ahead and list them because again, This is just the rainbow strategy. This is not the actual answer. The answer is going to be in list form. The actual answer is going to be 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120 are all factors of 120. Whew, that one was exhausting. You can see how the ones that you knew a divisibility rule for were a little bit less exhausting, right? Today, we're going to add to your list of divisibility rules, and we're going to discover the rule for 9.